This is the macroscopic question that we got from Unit Operation of Chemical Engineering 7th edition, problem 4.3 on page 96. The group members are Ahmed Al-Baloui, Hamad Al-Ajmi, and Muhammad Al-Ajaji. The question is, a water tank is 30 feet in diameter and the normal depth is 25 feet. The outlet is a 4-inch horizontal pipe at the bottom. If the pipe is sheared off close to the tank, and here's a picture of the tank where it is 25 in height and 30 feet in diameter, and here's the outlet pipe, which is 4-inch. And the first part A, what is the initial flow rate of water from the tank? Neglect friction loss in the short stub of pipe. B, how long will it take for the tank to be empty? Here is part A. First, we started with the mechanical energy, which is delta EK plus delta EP plus delta P over rho equals negative friction loss plus work shaft. The delta P will be neglected because there is no difference in pressure. The friction loss is neglected as it's shown in the question. The work shaft is 0 also because there is no work that comes out from the system. Here is the delta EK. We assume the first velocity equals to 0, and this is going to be the equation. V2 squared over 2 equals plus G delta Z equals 0, and so we'll need to find V2, which is the final velocity, and it equals square root of 2G delta Z, and then we substitute all the unknowns here, and we got 40.11 feet over second. Now we need to find the volumetric flow rate, which equals the velocity times the area. We already got the velocity, so we got the area, the cross-sectional area, which equals by radius squared, and that equals 0.087 feet squared, and we multiplied the velocity times the cross-sectional area that we got. So the volumetric flow rate will equal 3.5 feet cubed over second. Part B, we got this equation, and we neglected the mass flow rate that goes out of the system because that goes inside the system, because there is no mass flow rate that goes in. There is only mass flow rate that goes out. The dm over dt will equal rho times dv over dt, and the mass flow rate that goes out will equal to negative rho times v, which is the volumetric flow rate that goes out. And always the incompressible will equal to rho, it's going to be rho is constant. The volume of the tank will equal to pi times radius squared times z, and the volumetric flow rate that goes out will equal to cross-sectional area times the square root of 2gz, by times r squared times dz over dt will equal to negative cross-sectional area to the square root 2gz, and that will give us, if we substitute, that will give us pi times 15 squared dz over dt equals negative 0.08 times square root of 2 times the gravity, which is 32.174 times z. And if we integrate that, that will give us this equation, which is the z initial will equal to 25 and the z final will equal to 0, and the t initial, which is 0, and the t final, which is the time that we want from the question, and that will give us the time will equal to 10,123 seconds, which equals 2.81 hours.